Hey everyone, welcome back. Today we're going to look at inequalities of nonlinear systems. We're going to use a lot of what we've previously seen before, so nonlinear systems, inequalities, and quadratics. We're going to be using a lot of that stuff in today's lesson. So in this lesson, you may round your values to 2 decimal places. So let's get started. Example 1, graph the system. So y greater or equal to x squared minus 1. So this is our x squared minus 1, like that, down by 1 as such. And it is greater or equal, so it is a solid boundary line because you're allowed to be equal, and it's above x squared minus 1, like that. Our second equation here, or inequality, y less or equal to x plus 1. Right, so you go up 1 and then you do your slope of 1, over 1 up 1, over 1 up 1, and so that is our x plus 1, like that, and we are below it, like that. So what's in common is this area here. This is the solution region of the system. Now this is something that you should ask your teacher. Is this good enough, or do you require more details, such as the intersection points, like that? Specifically, what are those values? So I'm going to assume that your teacher says yes, you need those intersection points, and so we're going to cover it in this video. But if you don't need it, you can skip over, no problem. Okay, so we're looking for intersection points. So we're going to do a substitution. So y equals x plus 1 and y equals x squared minus 1, like that. So we're going to do substitution where we plug this into the other one, like that. Now we're looking to solve it, so we're putting everything to one side. Turns out we can factor it, right? Product -2, sum -1. Those two numbers are -2 and 1. So we rewrite it as x minus 2, x plus 1 equals 0. So what are the values that you plug in to get 0? 2 and -1. So when x is -1, we plug it into one of our functions. We get y equals 0. So that's our first intersection point, -1, 0. For x equals 2, we plug it into our equation. We get y equals 3. So the second intersection point is 2, 3. And so this is an updated graph of the system. Point A, like that, and point B, like that. Okay, B, y is less than x squared plus 2. So we're going up by 2, and then there's our x squared, like that. It is not allowed to be equal, so it is dashed, and we are below x squared plus 2, so we are underneath it. We're also greater or equal to -x, so here's our -x, like that. We are allowed to be equal, so it's a solid boundary line, and the solution region is in between those two. Okay, C, -x squared plus 3, so 1, 2, 3, and then -x squared, like that. And we are below or equal, so it's a solid boundary line, and it's below, like that. Greater or equal to x minus 1 squared minus 2, right? So the vertex is 1, -2, right? So 1, -2, like that. And then there's our other quadratic as such. And so in between is the solution region. So more details, right? Point A and point B. So we're going to go a substitution again, as usual. This is very easy to do. So we have them equal. We're going to expand this like that, put it all on one side, divide by 2, and we get x squared minus x minus 2, like that. We can factor these, so product -2, sum -1. These are the two numbers, so we can rewrite it as x minus 2, x plus 1. What are the values that you plug in to get 0? 2 and -1, like that. When x equals 2, we plug it into one of those functions, whichever one is fine. Plug in 2, we get y equals -1, so that's our first point here. 2, -1, like that. When x is equal to -1, we plug it in, we get y value of 2. So -1, 2, -1, 2 is the other point, like that. Okay, time for some practice. Graph the system, A, B, C, and D. Go ahead and pause the video and answer that. Okay, A, x minus 2 squared, here we are. X plus 2 squared, here we are. Above both is this section right there. And if you want to write 4, you can, right? If you plug in x equals 0, you get y value of 4. So 1, 2, 3, 4, like that. Okay, B, x squared minus 3, like that. We are greater, so it's above. Y is less than a half x. So we got over 2 up 1, like that. That's our half x, like that. None of them are equals, so they're both dashed. So we're going to do more details, intersection point A and B. So we're going to substitute this into here. So we get x squared minus 3 equals half x. Put it all on one side, times 2 to both sides to get rid of the half. We're going to plug this into our quadratic equation, and we get 1 plus or minus 7 over 4. If it's plus, we get x equals 2. If it's minus, we get negative 1.5, like that. When x equals 2, we plug it into one of the functions. We get y equals 1. So 2 comma 1 is one of the points. Negative 1.5, we plug it into our equation, and we get negative 1.5 comma negative 0.75, like that. And so we label them here like that, A and B. Okay, C is relatively easy, right? So we have x squared less than that, so below that. It's allowed to be equal, so it's a solid boundary line. X minus 3, go down 3, and then slope of 1, over 1, up 1, over 1, up 1, like that. Not allowed to be equal, so it's dashed like that. So I omitted a few details. You could probably write 3 here at that point if you wanted to. Okay, D. Negative x, there's our negative x, greater than, so it's above, like that. Not equal, so it's dashed. X squared plus 2x minus 3. So we're going to graph that first. So we're going to do, we're going to factor actually. So we got negative 3, 2. The two numbers are 3, negative 1. So we plug that in. What do you plug in to get 0, right? This gives us our intercepts, negative 3 and 1, like that. So this is where you go 1, 2, 3, like that, and 1, like that. Vertex is in the middle of the two, so x equals negative 1. We're going to plug that into our function to get the y value of negative 4. So here we have negative 1, negative 4 as our vertex, like that. And so we can graph our function. Notice that intersection point A and B, like that. And so we're going to do that right now. So the quadratic equals the linear equation, like that. We put it all on one side. We use the quadratic formula, and we get negative 3 plus or minus root 21 over 2. For plus, we get 0.79 approximately. For negative, we get negative 3.79. So for 0.79, we plug that in, and we get negative 0.79, like that. Plug in negative 3.79, and we get 3.79 as the y value there. And so we update our points here. So there's A and there's B, and then those are the intersection points. And that's it. It's that easy. I'll see you guys in the next video.